Chapter 6.4 exercises 23 through 34. This section has to do with polar coordinates. We're going to do the odd number problems in these exercises. In exercises 23 through 26, polar coordinates of point P are given. Find all of its polar coordinates. So basically, the situation is that if we have a polar coordinate here of 2 comma pi over 6, what that is, it's a it's like we have an angle of pi over 6, which is going to be right here in quadrant 1, and this length here is 2, and the angle of rotation is pi over 6. So I'm going to rewrite that pi over 6 right here, pi over 6. That's our angle of rotation, which is 30 degrees. And so now we're asked to find all the polar coordinates. So that's going to be this distance of 2, angle of pi over 6. And what we have is a multiplicity of rotations. So if we rotate this angle another full rotation, and another full rotation, and the angle of a full rotation is 2 pi. So what that gives us is we can rewrite this and have a more broad statement as 2 comma pi over 6, and then 2 pi over 6 we can add plus 2 n pi. And what this means is we take 2 pi, which is a full rotation, and multiply that by n. So n will be any integer, and it will make this relation work. But what happens is that in polar coordinates, we can also have a negative radius, in this case -2, and for that, if we go to -2, which is the opposite direction, I'm going to take that -2 across over here. So with an angle of pi over 6, -2 would come over here to where this purple line segment ends on this circle with a radius of 2. And so for that, that would be a radius, and what we have to do is rotate by pi to get back here to the original location of this 2 comma pi over 6. So for this one, we have to multiply by 2 times the quantity n plus 1. Times pi. So this n plus 1, really, what this does is it makes odd numbers of pi. So if we make n be 0, we would have 2 times 1 times pi, 2 pi. Or if we had n as 1, we'd have another 1. So it's sort of like we're out of will be out of sync with the original, but that adjusts for this plus 1 pi. So that's kind of hard to visualize maybe. And then for these situations, n is an integer. And integers can be what? Positive or negative. So those will be our answers for problem number 23. Problem number 25. We have the same situation. The polar coordinates this time are 1.5, so radius, and negative 20 degrees. And so just kind of lining out where we are. We have a coordinate plane here. We have a rotation of negative 20 degrees, so I'll put this right over here in quadrant 4. And this will be a distance of 1.5, and this angle here is going to be negative 20 degrees. So that's going to be the angle separation from the x-axis to the bottom side, and then we're going to draw a point over here to the right. So what we have for this is, now what is the rotation going to be? Rotation is going to be how many degrees? Well, back in problem 23, we had our rotation of 2 pi. In this one, however, we're going to have a rotation in degrees of 360 degrees. Okay? So what we're going to have for this is to find all the polar coordinates. We have 1.5, and that's going to be comma, negative 20 degrees, and that's going to be plus 360 times n degrees. Okay? So that's one of our possibilities. And then just as we did in problem number 23, instead of going positive 1.5, we can go to negative 1.5. But to access that, we would have to go the other direction on the opposite side of that circle. And over here, we would have, from standard position, a starting angle of 160 degrees, which is going to be just 180 degrees added to negative 20 degrees. And so for this one, we're going to start at 160 degrees, and that's going to be the same as the other one. It's going to be plus 360 n degrees. And the same condition as for problem 23. N is an integer. It'd be nice to be able to spell integer. So that's problem number 25. Okay, problem 27. Exercise 2730, rectangular coordinates of point B, point P are given. Use an algebraic method and approximate exact solution values with a calculator when appropriate to find all four coordinates of P that satisfy. And we have different intervals between 0 and 2 pi, between negative pi and pi, and C between 0 and 4 pi. And so what we're looking for is this point 1, 1, and okay, this just kind of drawing a coordinate plane. if we draw the point here in quadrant 1, which is 1, 1, that's a rectangular coordinate. What that is, that's going to be consistent with an angle of 45 degrees, or pi over 4 radians. And as far as the magnitude, well, the magnitude is going to be simply, just get rid of that pi over 4 there. Oops, that back. What that magnitude is going to be is simply, we have an adjacent side of 1, and opposite side of 1. We have our magnitude, or our radius, is going to be equal to square root of 1 squared plus 1 squared, using our distance formula. So we're going to have square root of 2. So for this one, our polar coordinate in between 0 and 2 pi, now 0 and 2 pi, that would mean a full rotation of a circle. All right. So for that, what we're going to do is take, this will be answering part A. Our polar coordinates are going to be square root of 2, which we established is the radius, and in radians we have pi over 4. Now, another thing we're going to have is, what if instead of a radius of pi square root of 2, we went the other direction, which I'm doing now, and we would have to rotate another 180 degrees, and 180 degrees equals 4 pi over 4, right, or pi. So we could take negative square root of 2, comma, and we can just add 4 pi over 4 to pi over 4 and get 5 pi over 4. And so really, that's all we have. And what else? That would be for part A. Now for part B, now remember in part B, we're going from negative pi to pi. Well, still this first set of coordinates would apply. So we're still going to have square root of 2, comma, pi over 4 as one coordinate. But we're going to be going the other direction. We're going to be going, instead of plus 4 pi over 4, we're going to take pi over 4. Instead, we're going to subtract 4 pi over 4. So we're going to get, for that, negative 3 pi over 4. And so we're going to have, again, we're going to have a negative square root of 2, but this time, comma, we'll have negative 3 pi over 4. And this negative 3 pi over 4 is going to occur between 0 and negative pi and 0. All right? And then for part C, in part C is going to be between 0 and 4 pi. And to find out what that is, well, we're going to have answers from part A. So answers from part A . Okay. And we're going to have square root of 2 and in this case we are going to add not 4 pi over 4 but 8 pi over 4. So we're going to have pi over 4 because the entire rotation is 2 pi. Well, 8 pi over 4 is equivalent, right, to 2 pi. So we're going to get 9 pi over 4. So 9 pi over 4, that's our other, and we could write it, usually you'll see 9 pi over 4 written like I'm going to do now. Usually I would see it written as 9 pi in the numerator, 4 in the denominator. And, or, if we take negative square root of 2, in this case we're going to have to take this pi over 4, or this 9 pi over 4, and add another pi over 4 to get it, 4 pi over 4 to get it back to the other side. So if we add another 4 pi over 4 to 9 pi over 4, we're going to get 13 pi over 4. So 13 pi over 4 is our last part of this answer. So here we have parts A, B, and C. So if you just take a circle and just kind of think as you go, this thing shouldn't be that hard. Next odd number problem, which is 29. Now in this case, same conditions, except we're given a point which is negative 2 comma 5, and that's going to be a point which I don't think is going to be a one of the 16 points in our unit circle like we had problem 27, that pi over 4, right? So we're going to have to find out where we are, and to do that we have to use an algebraic method. So we have negative 2 comma 5, so there's negative 2 and up 5, 3, 4, 5. So here's negative 2 comma 5 right up here. And now to get what we need, we need to find out how far the direct distance is. Here I'm dropping like a reference angle straight to the x-axis in red. And let me make this other say we are looking for this radius that I'm now drawing in red. Okay, that's going to be what we're looking for. And if we have negative 2 down here as our adjacent side, and 5 is our opposite side, our magnitude, or our r rather, is going to be the square root of negative 2 squared plus 5 squared, and that's going to be square root of 4 plus 25, which equals square root of 29. And to find out what angle is, well, if we take our angle is going to be inverse tangent of opposite over adjacent, which is going to be 5 over negative 2, we're going to get an answer of a negative angle. It'll be this, I'll call this theta prime over here in purple. So we go here, and so we have this inverse tangent of, we'll have 5 over -2. So we get this for an answer. Well, to be consistent in these exercises, in this exercise set, we're going to have these in radians. And so we're going to take this -68.2 degrees essentially, and we're going to convert this to radians by multiplying by pi over 180. So here we go, from pi over 180. And this will be the radian rotation. And so we're going to get negative 1.19. Now what we're going to do is, that's going to be negative 1.19. It's going to be this rotation here in radians where theta is. So theta prime approximately equal to negative 1.19. Well, to get this angle as a positive rotation, we will have to say theta is going to be equal to pi, or pi minus 1.19, right? So we go back to our calculator, and we're going to put in pi minus control answer for A and S. Actually, it should be plus 1.19, right? Minus negative. So it's going to be pi minus 1.19, and we're going to get 1.95. So the polar coordinates here are going to be, for part A, square root of 29, comma, 1.95. And, or we could say, or I'm going to bring this below to save space. If we go the opposite direction, if we go negative square root of 29, what would we have to do? Well, what we'd have to do is add pi to that. And so we would add pi to this 1.95. So we go to our calculator and put in plus pi. We have 5.09. So here we have 5.09. Okay, so that's part A. Now part B, we're going to have the same things we had above in this first part, because we're looking between negative pi and pi. So we're going to have square root of 29, and we're going to have 1.95. And 1.95, what is that? That's going to be this angle right here, 1.95 radians. 1.95 radians. That's what that angle is. Or if we have negative square root of 29, now remember, we're having an angle going to a negative side. So if we take negative square root of 29, it's going to be down here, like I'm making here in purple. Well, what that is going to do is going to rotate the opposite direction. So it's going to be negative 1.19. There's negative 1.19. We got to rotate another 180 degrees. So it's going to be negative 1.19. So that's going to be part B. And part C, we're going to have answers from part A okay, answers from part A plus what we're doing is we're keeping the same radius, but we're going to add another 2 pi to that. So we're going to take the 1.95, so 1.95 plus 2 pi. So we're going to get 8.23. So it's going to be 8.23 right here. Square root of 29, comma 8.25. Or we're going to take this negative square root of 29, and to that we're going to add pi to that, because that's going to be a half a rotation. So that's the out of sync phenomenon we're experiencing here. So go back to our calculator, and to this we're going to add pi radians. So we get 11.37. Looks like 11.37 radians. Okay. So 11.37. So here we are. Problem number 29 worked out. So it just takes kind of logic of rotation as we go about our business here. In this case, we had to take, we had inverse tangent, got degrees, converge to radians, worked out problem in radians. Next on our problem, well, we have a set here. 31 through 34 is kind of a mix and match. Use your grapher to match the polar equation with its graph. So we're going to have to locate how we graph polar equations in our TI Nspire CX calculator, and we're going to try 31, which is r equals 5 cosecant theta. So we go ahead and control I, and we're going to get a graph here, and to graph, let's see, we're going to get a menu, see if graph entry edit 3, and we'll pick function. Well, we're going to look for a polar, right, which is option 4. We go over to 4, and let's look at that again. We had 5 cosecant theta, so we go to 5 times, we go to cosecant, and theta, or theta, we can go to our Greek letters here on the left where this pi is, and go to the right there. So here we go. Here we go. There's theta, the graph, and we get a horizontal line here where y equals 5. So we go to our answer choices here, and it looks like that's what we have here. That's going to be answer choice B. So I'll put this little b next to 31. The next one on the problem to look at is 33. R equals 4 cosine 3 theta. So we go back to our calculator. Go to control I. Excuse me. equals, and we're going to go get our graphical menu, graph entry edit, polar, and it's going to be 4 cosine 3 theta. So 4 cosine, and in this argument we're going to put 3. I'm going to get our theta again. Enter. And we have this graph. Well, we have this 3-leaf arrangement. Go to our choices. It looks like that's going to be answer choice C. Choice C. And 32 and 34 are going to be just as easy to find. So those are all the odd number problems in this set. Really the first part of it, problems 23 through especially 23 through 26, and especially 27 through 30 take quite a bit of thoughtfulness, so good luck with these, and thanks for viewing.